All right, next we have sequences, and a sequence is an ordered list of numbers. It's a special type of function whose domain includes only positive integers such as 1, 2, 3, and so on. Each sequence is made up of numbers n, or terms, and the value of each term is called a. In an arithmetic sequence, the difference between consecutive terms, which are terms right next to each other, is constant. Its function rule has this form: a equals an plus b. Well, guess what? This little a is the same as the little a that we did before. So a is still output over input. This is my input, this is my output. Here, when we do a function rule, these first numbers are the positions. So this is the first number in the sequence 1. 2, the second number is 4. So my sequence would look like this: 1, 4, 7, 10, dot, dot, dot. I want to find a rule so that I can figure out what the next one is. And I know that you can see that, oh, look, we're adding 3, we're adding 3, we're adding 3, so we keep adding 3. But if I want to know what the 100th number is, I don't want to have to keep adding 3 100 different times. So I'm going to go ahead and figure out what my sequence is. So here I still figure out that, okay, these are all changing by +1. And these, like I just said before, we're changing by +3. So my little a is output divided by input. So my change here is 3. So right now I have a, capital A, equals 3n plus b. Well, look, these are the n's and these are the a's. So I'm going to pick an ordered pair, input output, just like I did before. Again, I don't have a 0, but 1, 1's a pretty good one to use. So if I choose 1, 1, then my capital A is 1 equals 3 times my n is 1 plus b. So 1 equals 3 plus b. If I subtract 3, I end up with b equaling -2. So I have my a and I have my b. So my sequence rule is a equals 3n minus 2. So watch what happens. 3 times 3 is 9, minus 2 is 7. 4 times 3 is 12, minus 2 is 10. So if I want to know when n is 100, like I said before, I can plug it into my rule now. I can say a equals 3 times 100 minus 2. So the 100th term is 300 minus 2, which equals 298. That's a lot quicker than going 1, 4, 7, 10, 13, 16, etc. and doing it until I get the 100th position. Let's try one more of these. So here now I'm just giving you the -3, -1, -3, -5, -7. So I know my position always starts with 1. This is the first position, second position, third position, fourth position, etc. So 1, 2, 3, 4, n, the n position. And then we've got the value of the term, and that's where these numbers go in. So -1, -3, -5, -7, and we call this capital A. So here we go. We're going to build A equals A sub n plus B. So my lowercase a is again output divided by input. My input, these are all changing by +1. My output, these are all changing by -2. So it's the first time you've seen that it's gone down. So my A is output -2 divided by input 1. So A equals -2. So far, my function is a equals negative 2n plus b. Now I need to choose a point. Let's get bold and choose this one right here instead of going to the 1 and negative 1. So I'm going to choose 3, negative 5. My capital A is the negative 5 times negative 2 times n is the 3, and then plus b. So negative 5 equals negative 6 plus b. Add 6, and I'll come over here, b equals 1. So it looks like my function should be a equals negative 2n plus 1. And we can check it. Negative 2 times 2 is negative 4, plus 1 is negative 3. Negative 2 times 4 is negative 8, plus 1 is negative 7. So let's say again, I want to know what is it for the 50th position this time. So 50th position. So a, the value of the term, is going to be negative 2 times 50 plus 1. So that's negative 100 plus 1. So in this sequence, the 50th term would be negative 99. And again, I think that's a lot quicker than keeping on with the sequence, negative 9, negative 11, negative 13, etc. Okay, so come in tomorrow prepared with questions, and I do expect that you have all these notes written down. If you didn't get something, guess what? You can start the video over. I will talk to you tomorrow.